Okay, in this video we're going to look at factoring polynomials. Okay, so first of all we're going to consider a polynomial, this cubic polynomial. And if we want to factor it, well, we can't use the standard factoring rules that we had for quadratics. So we're going to look at using the factor theorem for this. And if it did factor, at best it would factor to something like this: x minus k1, x minus k2 times x minus k3. At worst, it's going to look like this: x minus k1 times some quadratic. Okay, so in this one here, we're looking at ones where the leading coefficient is just a 1. Okay, so that makes this x squared, not ax squared. Okay, so when you multiply this out, now when you look at this, if you were to multiply this form out, you'd have the first terms, which would make up x cubed. But these constant terms, k1 times k2 times k3, would end up being 24. Or in this one here, k1 times c would end up being 24. That's the constant term if you multiply that all out. Okay, so if we know k1, k2, or k3, then we know a value of x that will make p of x equal to 0. Okay, so if we know one of these values, we know that p of that value would equal 0. And just by looking at that, we can see it. So if k1, if we knew what it was, then we could sub k1 into this polynomial, and it should give me 0. From the factor theorem, and also from this look, k1 minus k1 is 0, and 0 times anything is 0. Okay? So by the factor theorem, then x minus k1 is a factor of p of x, since p of k1 would equal 0. If you multiply the factor form of p of x, then you would get 24 equal to k1 times k2 times k3, the negative of it. And the negative of it, just because of the signs that I have here, negative times negative is going to be negative. Okay? Or you get 24 equals negative k1 times c from this last form. This means that to determine k1, you need to look for the factors of 24, the factors of the constant term. In here, you look for those factors, and you try those into p of x to see if it equals 0. So not nearly as nice as factoring a quadratic, but you do have a bit of an educated method for finding this. So you look for factors of 24, try them in here to see if you get 0, and if you do, then you know that x minus that number is a factor. Okay? So for this one, you're going to look at factors of 24. Factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24, positive and negative. Okay? So those are the factors here, the positive and negative. Once you've found one, you try them for x in p of x until you get 0. Okay? And then you'll have a factor for p of x, which would be x minus k1. Or k1 is a factor of 24. So if you try some numbers here, so 1 is a factor, that's 1 is part of our list, but p of 1 does not equal 0. Neither does p of negative 1. So x minus 1 is not a factor, x plus 1 is not a factor. But p of 2 is 0, and that implies that x minus 2 is a factor of p of x. So if x minus 2 is a factor, then we can divide that in. We can use our long division to find the other factors. Okay? So we're going to divide this now. So divide p of x by x minus 2, and you're going to get q of x. So just like when you have it in this form, p of x divided by x minus 2 equals q of x. And the remainder, of course, would be 0 because it's a factor. Okay? So I'm using synthetic division here. And when I divide it, I get q of x equal to x squared minus x minus 12. Okay, so I'm dividing by x minus 2, so I put minus 2 here, the coefficients of p of x here, and I follow through. Okay? So you can pause the video and try it and verify that you got the same answer. And if that's the case, then if I look at this division, if p of x divided by x minus 2 is q of x, then p of x equals x minus 2 times q of x. Okay? These two multiply to get you that. So I've got q of x, which is this. I got x minus 2, so x minus 2 times that is going to give me p of x. So I've factored it. I haven't factored it completely, but I've factored it in two pieces. Now all that I have left is a quadratic. So I've got a quadratic here. I can just use standard methods for factoring that. Two numbers that multiply to negative 12 and add to negative 1, negative 4 and 3, and there, I've factored that quadratic. And that means now I've factored that cubic. Now if that was not a cubic, if that was a quartic, then q of x would be a cubic. And you'd have to go through the same process to factor that cubic until you got down to a quadratic. Okay? Now, what if the leading coefficient is not 1? So, for example, if you had something like this, okay, then the factors may not be as nice as you had before. They might look like this, where you have numbers in front of the x. And all these numbers in front of the x, a1, a2, and a3, would multiply to give you 12. And all the numbers at the end, k1, k2, and k3, would multiply to give you 6. So at least it would look like this. a1x minus k1, and then I just called it a4, x squared plus bx plus c, so times a quadratic. Okay? Now, if this is a factor, then what value of x would make this 0, which would make the whole thing 0? Well, the value of x that would make this factor 0 is k1 over a1. So a1's cancel out. k1 minus k1 is 0. So that means p of k1 over a1 would get me 0. So we're looking for the factors of 6 divided by the factors of 12. Okay, so we need to find k1 over a1. When we look at these factors, and they're going to look like this. k1 over a1 equals positive or negative factors of 6 over the factors of 12. And the first ones you're going to try are 1 over 1, 2 over 1, 3 over 1, 6 over 1. So just these numbers on the top, and then 1 over 2. Well, 2 over 2 is the same as 1, so you don't need to try it. You've already tried it. Then 3 over 2. Then 6 over 2 is 3. You've already tried that. And so on. Some of them, the list will get less and less as you go on. So when you try these, you'll find that p of 1, p of 2, p of 3, and p of 6, none of those equal 0. So you have to move to the fractions. Okay, so all these whole numbers don't equal 0. But if you try 1/2 into the polynomial, so you plug 1/2 into here, you'll find you get 0. And that will mean that x minus 1/2 is a factor. And if x minus 1/2 is a factor, then so is 2x minus 1. Double that. Okay? So now we're going to do the same thing. We're going to divide p of x by 2x minus 1. Okay? Divide p of x by 2x minus 1. And we'll get q of x. And then 2x minus 1 times q of x will equal p of x. To do this, we're going to use synthetic division. So remember that's the value that makes x this piece 0. So it's going to be 1/2. Sorry, negative 1/2, not the piece that makes that 0. So negative 1/2 you put out here. And then the coefficients of p of x. And because this is 2x minus 1, we're going to get double the answer. So we got 2q of x. This is how synthetic division works when you're dividing by something with a number in front of the x. Okay? And then divide everything by 2 and you've got q of x. Now you've got p of x factored. It's 2x minus 1 times q of x. Factor that quadratic with standard methods. And then p of x is this, nice and factored. Okay. And here's another example for you to look at. You can look at the question, pause it, and try it. And then here is the solution to it. Okay. And that's it for factoring polynomials.